tonight we're going to be talking a little bit about experimentation, and I know that this term has many connotations for different fields. For in the software industry or the tech industry, most of the people will think about A/B testing. And when you think about A/B testing, at its most basic form, it's just comparing two things, different things, and see which one performs better, right? And before I keep going, I just want to know, like, how many of you have PM one A/B experiment in the past? Okay, just keep your hands up. Like, what about 5? 10? 20? Okay, so maybe I won't be able, you may be able to teach the class instead of me, but just wanted to get a sense here. So for the people who do not know much about it, let's start with a very simple example, right? When you're thinking about A/B testing, the first thing that you want to think is, like, what do you want to test? So let's say that you have a website that has a buy now button. Right now is red, and you want to change it to a different color. So you know what you're going to test. So the second question about that, about doing an A/B testing, is like, what do you want to change? You think about making it better. Let's say that you want to improve the number of clicks. So that's your success metric, and then you randomize who is going to be accessing from all your traffic. Like 50% goes to your control, 50% goes to variant, and then you just measure the outcome, and that's it, right? And it's actually that could be as simple, but even when you're thinking about that, it's so interesting how such a simple concept can go wrong in so many different ways. So I think that that's part of what I want to talk to you about it, about why it's really good to do A/B testing or other types of live experimentation, but also to know when it's not the right way to do it. And there are so many other methodologies to use to understand how users work or how users think. So it's just another tool in your toolkit. As I say, because lately there are many tools that make A/B testing so easy to use. And it's very straightforward. You have two things, you check one variable and see which one is better, right? And that means that so many people are running A/B testing, and so many people who do not have a statistical background. And that could be very problematic, because you could be running a test that is not well designed, and yes, maybe you will make a bad decision, but you also could just waste a lot of time, or you could make a potential disastrous decision with your company, right? So it's important to understand that not because it's there and it's easy and it's available and everyone can just use any tool to do it, you should be using it. I've met many people who use A/B testing because they don't really want to think what's best, and they just put it out there, or they really don't know anything, and it's just like a hunch that they have, and they spend so many resources for no reason. So as the quote say, if the only tool that you have is a hammer, you treat everything as a nail. So what I want to talk to you during tonight, first, I want to talk to you about user research. I know that this is not exactly what you came here for, but I think it's important to understand what are all those tools that you can use, and experimentation or A/B testing is one of those. So after we go through that, then we can talk about, like, what are these experiments, why it's important to run them, and we can go then into a deep understanding on this live experiment. You will understand the difference. A little bit of a process overview. I will also talk about a couple of different methodologies that go beyond A/B testing. So I will be talking about multivariate testing and multi-arm bandit, and as well about some common mistakes and best practices about doing experimentation. So I love this phrase from Asimov. Asimov is one of my heroes since I was a kid. But this is the most exciting phrase to hear in science. It's not eureka, it's that's funny, right? Because you wanna see like what happened, like why is this behaving this way, right? And that's so interesting when you're doing experiments, at least from my point of view, that process of discovery. So what is user research? For me, it's kind of this love of learning, right? But user research is a systematic approach to discovering the user needs, pain points, and any information that can help you to understand a little bit more about the user. And when you do this kind of research, it really grounds you. It really like provides you those tools to verify and validate whatever you're building like actually makes sense. And there are multiple types of user research. I really like this framework that talks about user research based on 3 dimensions. The first one is the attitudinal versus behavioral. And this is very much about what people say versus what people do. I'll give you a good example. During my past employer, I was at Amazon, I was working for fashion. And in the fashion industry, when you are, for example, if you have a survey, people are very, they think about themselves very differently about what their choices are. Usually people think that they are very fashionable, that there is an aspirational goal. So the choices that they will say are actually very different than when they are in an actual situation, and the choices they make to say, this is too expensive, I'm not that fashionable as I thought. So it's important to understand how the different research methods will give you a different flavor of what users think, or they think they think, or what they do. So this is another dimension is qualitative versus quantitative. And this is very much about there are some research methods that will be able to give you a lot of qualitative data about like why someone thinks about something. If you have an interview of like 30 minutes versus versus potentially having a survey or an experiment like A/B testing that we're going to talk, that you will know a lot about like how much, but you don't really understand the why. So that's why it's important to know like, what do you really want to know? Do I want to know the why, or do I just want to know like the behavior? And the third dimension is this context of use, because you can do research in a natural environment, basically like exactly how users are using your product. It could be kind of scripted, like you provide a guide, so people will go through the process and they will behave a little bit different. Or it could be completely not using the product, just to think like, just tell me what would you do in this scenario. And the last one will be a hybrid of some of those. Sometimes you do some kind of interviews that you want to understand how people think about something, and then you put a different product, for example, for them to interact, and then you can put your own product there. So there are multiple types of research methodologies. So there's this humongous landscape of user research, right? From focus groups that are very, it's about attitudes and it's about qualitative information. You may have something like usability studies, right? That it could be somewhere in between. It's a little bit more behavioral depending on how you design it. But it could give you, if you do it with 1,000 people, you will have quantitative data. And as well, if you ask questions about why did you use or chose something, you will also get the qualitative information. And here, right at the corner, is when you have this A/B testing. So this kind of A/B testing or clickstream analysis, this kind of research methodologies is, as I say, very quantitative. It just gives you an indirect reading of your users, and it's behavioral. It's exactly what they are doing. So where does it fit in product development? So research actually fits everywhere, and there are multiple types of research, from foundational research, iterative research, and evaluative research. So if we go to the foundational research, this is the time where you want to be very empathetic with the user, really understand what's going on, and as the name says, is the foundation of what your product is going to be. Like, why am I doing this? What kind of problem am I actually solving? This type of research will uncover opportunities. They will inform you about like your product direction, but even though it says that it's foundational, it is not only before you start working, like building your product, it's during the whole process of your product, because you always want to be engaged with users about how they feel, and be empathetic, because their needs change, they change. And this is where you have ethnographic field studies to really understand like how people behave. A good example that again, while I was at Amazon, I was able to go to Chile and Colombia and Mexico and really talk to people, sometimes in their houses, to figure out like how are they shopping online, like what are their attitudes, what are their problems. So you're right there. You will only be meeting a couple of people, but you get like really rich content. You can have these diary or camera studies where sometimes you have to actually follow a person for maybe weeks just to understand their behaviors. There are some decisions, for example, if you want to buy furniture, that you're not going to just do it in a couple of minutes, right? That's a process that could take weeks or months. So those are the types of research methods. For iterative research is when you are in this process of, okay, I want to explore. I have an idea where I'm going, but there are a couple of options that I can go, a couple of decisions that I want to make. And I want to identify if there's a problem with my approach before I release. And for this, you have different research methods where you want to do in-lab usability studies, where you have a concept that you want people to come and try it out and see, does this work or not? But you already have something in mind, and then you can say, no, this doesn't work. Let me try something else. You can have user testing, where you have just a script to send, as I say, 1,000 people. They follow certain steps, and then you start realizing, yeah, there are some problems here. And at the end, you have this research, but it is about evaluation, right? And this is how the product really performs with users, and how can you improve your product. And this is where you can have surveys when the product is already live. You can have, again, other types of usability studies, and this is where the experimentation comes into place, the live experiments. And so I just wanted to give you that overview, just to know that an experiment will solve some of your questions about product, but there are so many other ways to get it, because you have to understand that experiments you're actually testing with live customers. So you have to be careful. You have to be careful about what you test and why and how, because I think that for all of us, we don't want to feel that we are like rat labs. So okay, with that background, let's start with experimentation. So what is an experiment? So an experiment is a way to test a hypothesis about the quality of a product. It could also mean to the gradual launch of a product. This happens a lot in these big companies, at Google or Amazon. You have a specific product and you just want to launch it like a little bit to just a certain population. Let's see how it performs, and you keep increasing it. It's important to know that a test is not an experiment, and the big difference between tests and experiments is that tests, you already know the outcome. You know what it needs to happen, and you test and make sure that it happens. An experiment, you don't know. I mean, that's why you're doing it. Like, you actually have a question that you cannot solve. So when we're thinking about these two different types of experiments, most companies will be, or most people will be dividing them into the live experiments that you're testing as hypothesis, or a launch or evaluation experiment. And the ones that we're going to be talking here is about live experiments. So how does it work? again, the concept is simple. It can get complicated really quick. But you have a total population on whatever product that you have that people are accessing, and you can think about like the number of users, and then this is where you have to start thinking about like, what is my population? Is my population a user, or is my population a session, or my population is just a query? Like when I was in search, right? At some point, the moment that you start typing something and you search for something, that's it. Like that's the time frame that you wanna understand. It's not really the whole user journey, for example. So then you have all this your total population that comes to your website or to your app, and then there are multiple frameworks that can help you to divert that traffic. Usually, what happens is that you may have an experiment where you say, well, most of my traffic, I don't want them to see anything, so it's this unaffected population, and then you create your experiment with your control and treatment. And then, for example, in this case, if you have a type of experiment, you will put it just in the treatment group, and you still have the default values on the other two. It is very important that this randomization is done correctly, and we're going to be talking about that later, because if not, basically, it's useless. After, like, another important concept that we discussed before is, well, after you know what you want to test, you wanna make sure that you understand what is your success metric. So a success metric is this quantifiable measure of a desirable outcome, and depending on your specific product, that may be different. These are some random guesses about like what are the success metrics for some big product like Facebook. It could be like daily active users. For Airbnb, it could be like nights booked. For Amazon, could be revenue. So you have to select what's the metric that you want to monitor and to optimize to be able to run your experiment. The other part that is very important to understand is, like, no matter what experiment you're running, it is important to understand what is the long-term strategy, right? Is this metric that I'm optimizing now, is it good for the long term? And this could be long-term growth, financial, what have you, right? But we will talk more about the best practices about success metrics, but it's important that it is always aligned to what basically your team wants to do long term. So why to run live experiments? Many people would say, hey, I'm super smart. Like, I know what's going on. I know how this product is going to behave. It's so good. Like, this is going to work. Why am I going to spend resources on that, right? The issue is, like, humans, we're pretty bad at making predictions. We think that we know what's going on, but in reality, we don't know. And just to give you an example, right? I don't know if you remember this a couple of years ago, but yeah, I mean, we're bad, right? Like, we're really bad. And the interesting part is that we think that we're good, because now, if you know, like, a lot of people were saying, I saw it coming. Right? So this is a hindsight bias, right? You may be really bad at making decisions. Then you actually know the answer, and you were like, oh, I kind of knew it, right? You're still pretty bad, though. So we have those biases. There are multiple biases, like it's called like identifiable victim effect, right? Like, you know, like one specific user, you know, a specific scenario, and you think that that's the most important one because that's the only one that you see. Or it could be this observational selection bias that maybe someone looks like you or thinks like you, and you think that that's what is going to happen with the test, because if you like it, other people will like it, right? It could be projection biases, when you think that because right now you want it, it's really good in that specific moment, it will be good like forever. A great example for projection bias is going to the supermarket when you are hungry, right? At the moment that you're hungry, you're like, I want to eat everything, because at that moment you're hungry, but later you're not anymore. So that was a really bad prediction about how much food you actually needed. And you have anchoring biases, and there are hundreds. I mean, you can go to Wikipedia, and actually I went there, and there are like hundreds of biases, and everything applies. So we're pretty bad at making predictions, and that's why testing is a good strategy. Another reason why people will say don't do a test is you can just do a pre-pause, right? Like you measure whatever is happening before, and then you have your change, and you measure what happens after, and you will know exactly what happened. And that may be, I mean, it's not completely inaccurate, but the world is a fascinating place. There are many things that happen that you cannot really predict what is going to happen, and an event that could happen that will completely change your results. This is a great example from Google. So this is not real data, but this is search traffic that you have, you're measuring the traffic, and suddenly there's this big drop. Like, okay, so, and the problem or the issue was that the product team was released a feature at the same time, but they were not worried. And you're like, why you're not worried if at the moment that you released this, it went down, right? To give you a little bit of a hint, this happened in Brazil in June 2014. Any ideas why? Exactly. So yeah, so the World Cup happened during that time. People were not searching, so it didn't really matter, right? Like if you were doing just a pre-pause, you will be pretty concerned, but you know that, right? So that's why sometimes it's for attribution techniques, pre-pause is not that bad, but when you're doing a new feature, it usually doesn't help you much. Because the good part of an A/B test is that it really isolates the impact of just the product launches. So everything else being the same, what was the impact of my specific change? So reasons to do it is just to think about it. Is this a good idea? For example, in this case, let's say that you have some search results. And you have the search results in control with the specific title, with the description. But you know, people react well with images. So why not to put some images? This seems to be much better. But there are like pros and cons in this case. You're like, well, if I have pictures, it will be slower. Maybe I'm not going to be able to put the same number of results. What if I don't have the picture for every one of the results? So even though at the beginning it seemed like it's obviously good, right? When you start like digging a little bit deeper, then you realize that it's not as straightforward. You do have a hypothesis that with pictures you will be able to select a better result. But what happens if the better result is the one that doesn't have a picture, right? So that's a good I would say like test to say I don't really know what is going to happen. I do have a hypothesis, but I would like to check. Another will be when you already did an experiment and then and you realize that something is good, and now you wanna understand like, well, what would be the best iteration? And sometimes it's really hard to actually like you may have a couple of hypotheses, but it's going to be really hard unless you put it in front of users. So in this example, is to say, hey, I have my search results. I'm putting a specific URL, but what would make more sense to put it? To put the full URL, to put it like before the description, after the description. There are like pros and cons for both, and this is a good way to get the result. And there are multiple other ways, right? Like sometimes it's just about measuring impact, like how much is the impact of something that you're doing. You can test and then you can actually measure the value of it. Is something causing a problem? This could also be when you're releasing a lot of features, or you may release a feature that could be impacting latency, and you want to understand like, okay, how problematic it is, or sometimes like you have an actual problem and you don't really understand what is causing it, so you can create an A/B test for that. The one that I love is number 5. Like, is this still a good idea? And again, when you're working in these humongous companies, there's so much so many features that these products have, and sometimes it could have been a great idea like 10 years ago, but now it may not be. And when you start looking into this specific part of the product, you may realize that it's really hard to maintain. So sometimes you can say, what happens if we just remove it? Would users actually care about it or not? And also, what is the long-term impact of something? There are times where you want to do a test and just understand what is who is this population, and then just track them over time and see, well, maybe nothing happened, like there was very little change in the short term, but I want to see like what is the impact a year from now. But live experiments are not magic wands, so they are not going to be solving every single problem. And this is where science can help you a lot, to understand, like to figure out like how you should be planning, how you should be designing and analyzing these different experiments. So trying to bring the scientists in each one of us, let's talk about the fundamentals of experimental design when you're actually thinking about the scientific method. And this is something that I actually love to bring it to my conversations. It is science. Like, we're actually doing science. We're doing an actual experiment through the scientific method. And the scientific method has very specific steps. And if you miss one of those, it's not science anymore. Like, it doesn't matter anymore. And that's very tough for many people to get. It's like, well, it was almost there. Like, I'll give you more details, and people will say, well, it's fine, like we need to make a decision today that a population was not exactly perfect, but I'll take it. Like, no, it's actually wrong. Like, you cannot take it. And sometimes we don't think about science in this aspect the same way that we think about medicine, right? Like, well, it was kind of like, it worked kind of okay, but like, we didn't really like follow through every single variable, or maybe this person had a different reaction than the one that we were expecting, but it was still good, so let's go ahead. You're like, no, like, what happened? Like, why are you doing this, right? So really, I do encourage every one of you to think that this is science. There's a process, and you actually need to follow it. If you're not following, it's invalid. It is actually invalid. And I have these conversations a lot of the time with multiple teams. They're like, it's almost there. It is not. It is not. So what is the scientific method? First part is observation. And in the same way, like, you will observe the world, what is going on. You will do your research, trying to understand what is happening. Then you will formulate a hypothesis to say, well, based on this thing that is happening, I'm going to, I believe that something will change. So I'm going to use an example later on, so I will start here. So this is an example that I run, an experiment that many of you may have used on your app at Amazon. If you're a Prime member, there will be like a little filter out there that you can say, hey, I want just Prime products. And this started with an observation, right? With observation to say, hey, when I'm looking into our data, I'm seeing that a lot of people are filtering, but they're not really getting the right results. But I can see that when they filter and they use Prime, they actually are more likely to buy something. But it's really difficult for them to actually get it. So like, okay, so I'm getting this observation. I kind of understand a little bit more. So the hypothesis is like, well, maybe if I make it easier for Prime customers just to filter the Prime products, I think that it could be better. And then you start designing, like, so how am I going to do this? Like, how am I going to make it easier for these customers to do it? And in this case, it's like, well, should you just do it automatically? Should you change your algorithm? Should you have like a more prominent filter? Like, how do you do it, right? Then you actually run the experiment. You then analyze all the results, see like what changed, did it change the variables that I was expecting to do, what other things happened, and then you check and check if you actually prove or disprove your hypothesis, and that will give you also some other information to say, well, maybe I want to do a second test, or maybe I want to try something else or somewhere else. So with that in mind, let's go a little bit deeper into live experiments. So we went through looking at the process for science, right? Observation, hypothesis, design, experimentation, etc. But for product management, it could be a little bit different. So this is kind of like a flavor of the scientific method for product management, where you ask a question, or you have something that you wanna know, or you wanna test, or you wanna improve. You do this background research. You develop a hypothesis. The hypothesis is pretty similar. You analyze the data. You draw conclusions. You communicate results. It's pretty similar, but like just some changes here and there. So first, as a product manager, you have this question, right? Like, how can I increase my user happiness? How can I increase revenue? How can I simplify the code? How can I affect the behavior of my users? So you start having that kind of question that you want to answer first. And based on that question, then you start doing some background research. That is the observation, basically. But this background research is a little bit, depending on where you are, it could be a little bit different. The first thing that you have to do is a little bit of background research on, like, has someone tested this before? And if someone has tested this before, that doesn't mean that you cannot test it again. You just need to understand why is this going to be different. Like, why should I invest resources to do it now if it was done last year and it was not successful? So you do that background research, or you will find out that there were some learnings there that now they can be applied. And then you start going into this quantitative and qualitative data. The same way that I was telling you that I went through the different logs and see like how people behave with filters, trying to understand like, well, does it mean that if users use more filters, it's better? And then I realized that it's not. So I was able to track it, and say, hey, well, if users are using one filter, this is the conversion rate. If they use two filters, this is the conversion, 3, 4, 5. And then I start to understand like how the behavior works. So you do that kind of research, first quantitative, but then you then do it the qualitative. Like, do people, like in my design, like that I had this toggle on top, do they see it? Is it understood? And then you do other type of research. You don't do an A/B test right away, right? Like, you're still doing some research from the different methods. Like, you may do a usability test first. So you start getting all these learnings to be at a place when you put it in front of the customers, it's actually your best shot. You're not just trying to put something out there to see what happens, right? Like, I really think that this is going to work, and I did all of the work to make sure that it's going to work, but I don't know, right? I don't really know. So after you do all this research, you have to first of all, right, to develop a hypothesis, and I want to spend a little bit of time on this topic. A hypothesis is a testable explanation for a phenomenon. And it's important to understand these two parts, the part that is testable and the other one that is an explanation. So we will go through some exercises to see if a hypothesis, if whatever you think that a hypothesis is actually a hypothesis. And you do that before an experiment happens. And you need to have a hypothesis. You're not just putting something out there to see, let's see what happens. You need to, you should know, like, you should have an educated guess about what is going to happen. And then the idea of the experiment is to set out to prove or disprove that hypothesis. So let's do an exercise going back to our earlier example about having a buy now button in your website that is what's red and now it's blue, and try to figure out like, are these good hypotheses? So the first one is that the hypothesis is that this will make the product awesome, right? A question for the audience, is this a hypothesis? Why not? Yeah, I mean, it's like, what does it mean to be awesome, right? It's not testable. Or it could be, but you need something else, right? Another one. In our focus group, people like this design better. Is that a hypothesis?
So the result worth striving for.
Yeah, what is better, right? Like, yeah, so it's not a hypothesis. Like, there's no explanation. Like, why did they like it? You don't really know. What about click-through rate will increase? Is that a hypothesis?
Yes.
Are you sure?
Shouldn't it be stated in the negative?
Well, this is testable, but it doesn't explain why. Like, why is it going to increase, right? Let's take another one. So the color red is out of harmony for this world. Is this a hypothesis? Well, I mean, it could be, right? It's just that how can you test that the color red is out of harmony in this world? I mean, it's an idea, right? But you cannot really test it. What about this? Users associate red with danger. Is this a hypothesis?
Not for a product. Unless it's a product, it's different.
I mean, it is a hypothesis, right? Like, it's an explanation that users associate red with danger, and you can actually measure it. I mean, you can measure it like basically. I mean, you can put like people check their nervous system to see if they will feel like worse, right? And there's a lot of research that actually shows that it is true. Like, red is associated with danger, but in the context of our world, maybe not. That's not enough, right? I think that in the context of our world, like, we will need to like combine some of these concepts to say, well, I think that the click-through rate will increase because users associate red with danger, so they will be more likely to or less likely to click it, right? So you can create a hypothesis there. The main part here is that that you have, as I say, an explanation, and you have the part that is testable. The interesting part here is that I could see many things wrong with this part. With this hypothesis, just want to ask if you see something wrong with this hypothesis. I mean, it is a hypothesis, but what am I missing?
You're not really linking them both together. Like, there might be other reasons why the red is not clicking through so well as the blue one.
True.
But if everything else is constant, and it's just these two,
Yeah.
then there could be a correlation between the two.
Yeah. I mean, it's a correlation. You don't really know if it's because it's red. I mean, you know that changed, but that's how usually science works, right? Like, sometimes you don't really know. You have a hypothesis. There may be something else there. So my take here is like, not because you're making a test and suddenly you have these results, you are like 100% confident that it is true. Like, it is a hypothesis. The hypothesis in your scenario was true, but that's it, right? And the other part that I think that there was missing, and maybe it's because I lived in Asia for a couple of years, is that the color red does not look as dangerous everywhere in the world, right?
So what are we testing there?
So we're changing the color of the button, and the hypothesis is that because people right now associate red with danger, they will be less likely to click on it. But if you change it, it will be more appealing.
Okay, so you're trying to drive click-through rate.
Yes.
We don't really
Well,
care what nothing is. Like, red not, right?
Yeah, so that's a part like I mean, you don't really know.
Okay. Then how come you couldn't just pick the cursor as the only hypothesis?
Oh, you can have whatever hypothesis you want,
So you're
right?
not saying both of those two things.
Oh, I mean, you need to have both, right? Because if you only have the, like click-through rate will increase, like you have to have an explanation of why do you think that is going to increase?
Even if the second part might be nonsensical.
I mean, this has sense, right? Like there's actual research that shows this. This is not like a random thought that I
I
had.
believe the red performs better because it contrasts better with the blue background,
That's another hypothesis.
right? But
Yeah.
it might be because people associate it with
Yeah.
nature.
Yeah.
I
So
can prove the first part, but I can't prove the second part.
you can prove that the click rate, I mean,
You see where I'm going with this?
Yeah, yeah, yeah.
Because I can't prove both parts. I can prove one, right, not the other.
I mean, you can test one. The other one is explanation, right? This is the testable thing, and this is explanation. It could be another reason, right? But this
You
worked.
just gotta think through the second part.
Yes, you have to think like
You
you.
don't have to prove it.
You don't have to prove it, but you need to be able to have some background research, right? Like I'm not taking this thing about red out of my pocket. There's actually scientific experiment that show that based on what I'm saying, like you're actually measuring that. So it's true. So it's a true statement that you're just combining. Like maybe that's why it's happening. It may not be, but that's why it's a hypothesis.
So you're trying to drive a rigor in thinking.
Yes.
Not. Okay.
Yeah,
It's a rigor.
it's a rigor on thinking. And it's just to try to say, why are you doing that? Like, what makes you think that this is going to be better? So one rationale could be because the contrast ratio is much better, or it could be like it's more accessible. That's another reason, but at least you have something, right? It's not just because.
So you're avoiding people who are just randomly changing colors.
Like why? Yeah, like why do you think that it's going to be better? Like what kind of research did you do? Like what information do you have? Like what's behind that, right? It's not just like randomly think like, well, I'm just going to change it because. That's the part. Like that's the rigor that you need. But I say it's the same as science, right? Like you don't really know.
Why don't you just change it to every color and see what happens?
Yeah, I mean, I'll say that as not a good practice. Because that means that's the case, right? Like, why are you spending so many resources when you can actually do a little bit of research and try to scope it?
So
Yes.
you talked about some long-term implications. So
Yeah.
many times this A/B testing will test something at a point in time.
Yes.
How do you know, or what do you do to understand its implications over a period of time and a long-term impact, or maybe even strategic impact?
Yeah. So there are different techniques that you can use for that. I mean, you can have short-term metrics and long-term metrics, right? And also, so as I said, you can also do the comparison of you have your two populations, you do the test, and as I say, you can just track it, and you will track like what happened to those people later on. So that's one option. Something that happened specifically at Amazon, that there was a very specific metric that it was the downstream impact. So you will, and that was created by these genius economists that I don't understand what's going on, but I kind of understand. But there were very specific signals that will measure like some of the action that will be better in the long term. So you're actually measuring both. What could be like the short term and the long term. The short term could be revenue. The long term is this long term impact that is based on different signals.
Like what kind of signals?
I mean, if you decided, for example, if you bought your first thing in a different department, like if you only use Amazon for books and suddenly you buy TV, you're like, oh, that's a great signal. Like that specific signal, even though like it could be the other way around. Like, it could be just TVs, and even though like what you're buying is like pretty cheap, so in your test it's like, oh, I'm getting less revenue because now this person is buying a book. Like, yeah, but suddenly this person like crossed to another category, and there are studies to show that as people are crossing to other categories, that's a great signal, right? So short-term impact is not great, but long-term impact, there's some economic research to show that's a good one.
customer feedback or user feedback. That's
Yeah.
how you build requirements for
Yeah.
features or products.
Yeah.
That seems to be either in contrast with an A/B test approach or maybe complementary to it.
Yeah, complementary. Yeah.
Because here you're more reliant on data and observation
Yeah.
versus direct customer interaction.
Yeah.
You're building a hypothesis instead of talking to a customer about what he or she really wants.
Well, you need to talk, you may need to talk to customers to create the hypothesis, right?
Fair, but I think the origin of A/B test, as at least through the slides that I saw,
Yeah,
was
so
through data.
the only thing that an A/B test will tell you is like what happened. It won't tell you why.
Correct.
So that's why it's so important to realize, like, is this the actual research method that I need to answer my question, right? Because if sometimes there will be people that come and say, hey, I want to know why this specific name of a product resonates more with my customers, and I want to do an A/B test. And you're like, I won't be able to tell you why. I mean, I will tell you like how many people like clicked on it, but that doesn't mean that it resonated. Maybe it was because they were more confused. So,
I guess
yeah.
the question is because if you are getting a constant stream of customer feedback or user feedback, then how important is an A/B test at that point? Because if you really are getting good feedback from a significant sample size of customers,
Yeah.
then does it really matter to still do a test and verify a hypothesis?
Well, the issue that you wanna, this is when you're like making a change, you have an idea, you're going to change the product, you wanna know like if it's actually going to be better, right? As I said at the beginning, we think that because we did all this research, because we talked to customers, because we look at the surveys, whatever we're designing is great. What do you mean? What do I have to test? It's great, I already know, I'm super smart. But that's the part, like we're pretty bad at doing those predictions.
In isolation, I understand, but if you still have a pretty big sample size of people who have confirmed your...
Oh yeah. So there are. I'm not sure if this is where you're getting, but you shouldn't be testing things that you already know, right? Like there are sometimes they're like, oh, I wanna, I don't know. I'll give you a bad example, but at some point it's like, oh, we wanna. I'm not going to say Teams. I want to have this button bigger and have more clicks. And I'm like, sure, like if you make the button bigger, you will have more clicks. Why do you want to test it, right? Or like, I want to remove all the buttons and just have one to see if I will have more clicks. And you're like, yes, you will. So that's it, right? Don't do it.
I think,
But in some cases, you might still need to test it. Like at Amazon, for example, you want to know the bigger impact of having that bigger button to buying that product.
Of course, right?
Having that bigger button takes up more real estate than
Yeah.
that product.
Yeah, I mean, there are. It really depends on the context. My take is that's why it's important to know like the full context. What exactly is changing? What data do you have? Like you do need to like understand everything to say, you know what? In this case, it makes sense. But and that goes back to the slide about the hammer, right? This doesn't work in every single case. And you, as a product manager, you are the one who needs to figure out, like, is this the right tool for the things that I want to know or not?
I think your question was also around when you user tested and focus tested.
Yeah.
So user testing and focus group testing by definition is a very small group. So your product in the real world has to appeal to a large demographic, which you may not be able to cover in A/B testing or user testing.
Yeah.
We're pretty new in this journey where I work.
Yeah.
We're starting to find that.
Yeah.
It's usually under 30. Under 30.
But
Real life is under 5, to be honest.
Yeah, it's usually 5 to 10. 15 itself is considered fairly large for user testing. You tend to stick to 5 or 10. It will give you the result and it will give you this positive bias that, hey, I tested it, looks great. But then sometimes when you change something as simple as the demographic, the test fails. Right? So,
and that's a part of the context, right? Like when you're having this focus group, like people may not be using the product in that context, right? So and that's why, for example, sometimes when I was talking about doing ethnographic research and going to the people's homes to see how they shop in in their computer, in their desk, the way that they're going to be interacting is going to be very different than if you put them in a lab, right? So in the lab, they may behave in a different way because you're there, right? Oh, and I don't know what happened. Oh, it's because I got locked out. Let's see.
Unplug it and replug it.
Yeah. Okay. It's coming, it's coming. Okay. So let's go through an example with the example that I started to talk to you about before, about like developing a hypothesis. So you see here, let me just remove this. You see here the mobile app from Amazon. I'm searching for purple shirt, long sleeve. This is how things happen. And if you look at it, there are like over 40,000 results, right? And like, well, if I'm looking for a purple shirt, like, do you really have 40,000? Like, am I going to go through that? And we know from research that this number is very overwhelming. When people see like these thousands or millions, they're like, oh my God, I don't want to go through that. So like, how can we help that part, right? So the hypothesis here that I formulated, it may not, this is what I remember because it happened a couple of years ago, is that the Prime users will spend more money if they can easily narrow the search results to Prime products. And I developed that hypothesis because I did the observation, I did the research, that's something that it seems that, I mean, they do buy more of these products. I do know that people get overwhelmed with a lot of results, so maybe like reducing the number of results is better. I also know that reducing the number of results is not always better. So there are like conflicting ideas there, but I do have a hypothesis and I do have data that is backing it up, and I have something that is testable, right? I'm saying that people are going to be spending more money if they can find what they're looking for. So then the part is like, okay, now you have to design an experiment. So here the experiment that it was designed is like, well, let's show a Prime toggle on the navigation bar, and I'm very specific, like for all US customers on iOS that are Prime. So then this is the test. You have the control like here, and then I have the treatment like here, where I'm putting this kind of the toggle where people will say, well, it's off by default, and I will just give users the ability to opt in. So first, I want to have a conversation with you about the success metric. Like, what would you think? I mean, I chose revenue. Is that a good success metric? Like, what else could you have chosen? What? Okay. What else? What?
Time spent browsing.
Mm-hmm. I guess that you want to reduce it? Yeah.
Profits?
Profits is another one. And that's actually super important because that changes everything, right? Like, because that's basically like, you may have more revenue, but you may have less profit. Is that okay? Right? And also, like, purchase rate, yeah. Conversion. Another one will be that is usually problematic is like, are people using it, right? You're like, I don't care if they use it, right? And sometimes, for example, when you're doing, because we did a lot of filter redesign to make it like easier to use, like prettier, faster, and then we actually got results to say, yeah, people are using filters much more.
How about return rate?
That's another, like, I did a lot of tests about that as well. But yeah, it's basically like you really need to be very clear about what metric you want to optimize, because if you choose the wrong one, it's pretty bad. Like if you say, hey, I want to have this feature and I want a lot of people using it, you could get it, but then you can tank revenue. Or in your case, to say, if my objective is actually profit, and if the objective of the company is profit and I'm optimizing for revenue, I could tank other people's bottom lines. Then, yeah.
Did you try having it on default, like having it on default?
So this is a great example of when you're testing too many things at the same time, right? Because I didn't want to change the results. If you put it as on, you're changing two things.
But I'm saying, like, you know, you can have ABC, right? You can have the test at center.
You could, right? And we'll talk about like why sometimes it's good or not. But that's, for example, something to say, hey, just put it as on. You're like, well, in that case, you're changing the results and you're changing the action, right? So you're starting to test too many things.
We found when we did ABC testing that we got no clear winner. You get clearer winners when you're doing a balanced A/B test. With ABC testing, you find a loser but not a clear winner. It has been our experience.
Yeah, it depends. It depends.
Yeah.
Another part is like, okay, now you have your success metric. What about the triggering criteria? Triggering criteria, like to whom are you going to be showing this feature? And that's super important because if you, for example, say, I'm going to divide my traffic 50% and 50%, but most of them like are never going to see your feature, you're just basically like just losing, like you're not basically like how do you say, like capturing the actual change. Because if you change this, suppose that I'm changing this in search, but I don't trigger in search. I trigger when people go to Amazon.com. People will be interacting with the homepage and they're going to be browsing, and they will be part of an experiment. Like they will be part of my A or B, and they never saw this thing. So I have to be very clear about like at what moment am I going to trigger my experiment. So then you reduce your scope of people who actually see or not see that part, because if not, it just gets super noisy. And also try to understand, okay, what data do I have? In this case, I'm like, okay, I want to be a little bit more consistent. I understand like the iOS customers, the Android customers are different. Mobile web is different. The web experience is different. Like, where do I want to put it? Do I want to put this in the desktop? That's a completely different UX, right? And a different interaction. So try to reduce it to something that actually makes it easier to test. The other one is the duration of the experiment. We'll talk about that later. And this really depends on the sizing, on how much traffic you have, and how do you balance it, right? A good part that you need to understand also your users and the kind of behavior that they have. So in this case for shopping, you don't test something for a day or 2 days or 3 days, because a Monday is very different than a Wednesday or a Saturday. So you try to test it in chunks of like the whole week. So it's like a week or 2 weeks or 3 weeks, but maybe whatever kind of users you have at your product, maybe you can do it per day, right? Like I don't know, like you need to understand like what is a good capture of time like per week, per month, etc. And then one of the most important parts is this launch criteria. So when you do an experiment and you do it in the scientific way, before you do anything, you specify what are you going to do based on the results. So it's not just to see what happens, right? Like you have a hypothesis. I think that it's going to increase revenue. So what I'm going to say is that I will only launch this experiment if I increase my revenue by this much. And I put my seal there, and I will run this experiment for 3 weeks. Actually, it was 2 weeks, I believe, but anyway. And you run it, and you follow through. It's like one of the common misconceptions and problems is you say, oh, well, I'm doing it for 2 weeks, but I'm looking into week 1, and it's like, it seems that it's great, so I'll just stop the test. You're like, no, I mean, you basically completely like lost the science in your experiment, right? Like you change what were your conditions, or you will say, hey, 2 weeks, I still don't see that is good. Maybe put it 3 weeks and then we will know. Yeah.
Why are you sticking so much to the science here? Because maybe the cost of running that extra week kind of outweighs the extra benefit of the conviction that you will get after those.
Yeah. So the issue is that you should have known that before and consider it, but you're basically making a decision based on the results now. You're basically like you're how do you say, fishing for data.
Confirmation bias?
No, so, okay, so if experiment is not making a loss, that is, I mean, okay, there is a method to control it by controlling a traffic 1%, 0.5%, and then returning it, sure.
Yeah.
But if experiment is making a loss.
Yeah. Well, that's another part. You have to have an exit criteria. The exit criteria will say like, well, if this start happening, I'll stop it.
Right.
Yeah. An exit criteria is fine.
Okay.
Like, but suddenly like saying, hey, I think I will stop it now because the results are great.
No,
Yeah.
that's not fair.
Yeah, but sometimes, I think right now, because I attended this program training,
Yeah.
I talked about reaching significance.
Yeah.
And also making sure that you have 7 days interval.
Yeah.
So as long, I want to run the experiment for 4 weeks, but
Yeah.
at the end of 2 weeks,
Yeah.
I've reached significance.
Yeah.
Everything is completely green or completely red.
Yeah.
Stop it from stopping it.
It-
My second question
Yeah.
is, and this is not,
Yeah.
don't agree as well, but
Yeah.
my second question is around launch criteria. So
Yeah.
say this is your experiment, I
Yeah.
decide to launch
Yeah.
if revenue increases.
Yeah.
And after 2 weeks, I find out that revenue is actually flat or profit increased.
Yeah. So you shouldn't.
Business sense, like why wouldn't I run it even though it didn't go with my launch criteria, but like I have a good result, even though it's after the fact.
Yeah. But you don't like. You should know that. Like you should have that hypothesis before. If you're not.
The experiment is exploration too, right?
No, it is not actually. So the experimentation is just to validate a hypothesis. It's not an exploration. So you validate a hypothesis or not. That's it.
So would it be fair to rephrase you and say that you need to finish the experiments to have reliable data then that you could use then for further explorations?
Yeah. So the issue, like, it depends on how you want to do it. Do you want to treat it as science, or do you want to try to just check some numbers here and there and make a decision?
Experience, how often does the hypothesis get validated?
I mean, it depends. Not a lot. Yeah. Depends. Like, I've been in, for example, in some programs that are so bad that you have so much data that shows that, like, this is going, like, I'm pretty sure that this is going to work. So, like, in my last part, like my first 5 experiments were winners, and you're like, that never happens. Yeah, I mean, you're just giving a try. So I'm going to go a little bit faster because I have more things to say here. But the important part here is to analyze the data. You run the experiment. There are a couple of concepts here that are important to understand. Statistical significance is one of those. Is basically the likelihood that the difference between your control and treatment is not just a random. It's not by random chance. The other one is the null hypothesis. That's basically what an experiment is. The null hypothesis basically states that there's, like, if you do the control and the treatment, there's no difference. Yeah, there's no difference at all. So what you want to do is to basically reject the null hypothesis, because you're saying, yeah, it's going to be a different. I mean, that's why you're testing. There are other tests that you can do, A tests, where you expect no difference, but in most tests you expect that the A and B are going to be different, and you measure that through the p-value. So the p-value evaluates from the sample data if it supports if the null hypothesis is true or not. So that means that a low p-value suggests that it's not true. So that you're rejecting it. And that you rejected it means that it's different, that the control and treatment are different, and that's what you are aiming to do. And then you have these confidence intervals, that is the range of values with a lower and upper bound that is likely to contain one of the population parameters. This is a little bit sometimes hard to understand. So I have an amazing graph that I actually just took from the interwebs that helps a lot. Because sometimes people will say, oh, it's I don't know, it has a p-value of 0.05, so it's 95% confident that it's going to be within, like, that my actual revenue is going to be within the two boundaries of my confidence interval. That's not exactly what it means. I mean, it's similar, but it is not. So, for example, if you have here your mean of what happens is 2.5% that I said that it was the increase in a mean, and also you have the lower and the upper bound to say whatever percent up and down. So usually it will be like something like this, right? Like you only represented something like this, but in reality what it means is that you are like 95% confident. Like, it indicates that if you have like 20 different like new points in your data, it means that like 19 out of those 20 samples will cross your mean within their boundaries, right? So it doesn't mean that when you have your mean and you have your boundaries here, it doesn't mean that it will always be here. It means that this will be crossed like as things go up and down. So it's a little bit different than 95% confident that it will be within this. It may not make sense now, but it will at some point. So some of the things that it's important to when you're analyzing the data. So for example, if you say, oh, as I say, you say that A was 2%, it did 2% more revenue with a confidence interval of 1%. And then as you are plotting it in your graphs, when it doesn't cross the 0% boundary, like everything goes here, you basically say that it's significantly positive. And as I say, it's not that you have 95%, if you have a p-value of 0.5, it doesn't mean that the 95% will be here. I mean, it could also pass here because this could go a little bit like here. But in general, you know that it's around that area. And then if it goes to the other side, is significantly negative, right? So pretty similar. What happens most of the time when you do this kind of test is that it doesn't crosses. So it will be something in between. So you will have your lower bound will be below 0, your upper bound will be above 0. So what do? Like you don't really know. So in this case, it's inconclusive, and it is inconclusive even though the mean is positive, because you don't. I mean, there are a lot of chances. I mean, and when the bound is so big, there's so many chances that if you just move this here, it's super bad. So, but it could be really good too. So when you have those kind of tests, you're like, I don't know, like the test didn't tell me anything. And then you have this weird thinking that a lot of people use, that I also use, that is sometimes called as the flat result. Many people will say, I'm just doing this test for a no harm. Like, what does that mean? You're like, yeah, I'm putting this, just making sure that everything continues exactly the same. It's really, really hard to know like something doesn't do harm. Mostly everything will do some harm. It's just basically trying to realize how much harm are you okay having. Of course, if you have something significantly positive like over there, it could be great. It could also mean that you tested with too many people, but that's another conversation. So another way to do tests on this launch criteria is to create what it's called sometimes practical significance. So maybe it's not like statistically significant here or statistically significant here, but you can say, you know what, I'm okay if my confidence intervals will pass to the negative side by like 0.5%. So I'm okay losing up to like $1,000. Like it may happen. I mean, still positive, and it may happen. So but you need to be able to decide that before starting your experiment. You cannot just say, hey, I'm going to be launching this only if it's significantly positive. Then you do the test and it's something like this. And you say, I'll launch it because this was positive. You're like, no, that's not what you said, right? Like it's not having the effect that you were asking.
Why is it that bad?
Because
you decide you look at some results and then you have a discussion and you say, oh, it's fair enough. And
if you want to do science, no. I mean, if you get this, you don't know. You have no idea.
That is fair. What I'm
Yeah.
saying is, you suppose, okay, maybe better example is, suppose you say, I will launch it after 10% revenue increment. But you actually got a significant improvement. You got the green one, but you got 5%.
Oh, that's
then
fine.
you take a decision and say, oh, I won't do it 10%. I'll launch at 5%.
I didn't follow, sorry. So you're still in significant positive?
You are significant positive.
Oh, yeah, so that's depending on your launch criteria, right? Like most of my launch criteria will be as long as it's significantly positive, right? But just be consistent. Like if you start changing things, then you're not, you're just trying to cheat the system. And now you have to draw conclusions, right? Like you analyze all this data. In my case, for example, I realized in this test that way more people were using the prime filter. Way more people, because it's there, it's obvious. But someone was saying about conversion rate. The conversion rate went down because now more people have access to the prime filter, so more people are using it. So that means that before the intention of the customers was like, I want prime, so I had the intent to go to the filter and click there. So it was a little bit harder. So if they did that, it was more likely that they were going to buy something. But when they were just putting it there, it was so much easier for people who didn't even want it. So the conversion rate decreased, I don't remember, 3 times. But nonetheless, still with the conversion rate going so little, the revenue was way higher, right? And my launch criteria was that, revenue. It was not usage, it was not conversion rate, it was revenue. So usually when you have to draw these conclusions is first validation, making sure that you understand that the data makes sense, why is this happening? Description is basically go through your actual criteria, and then you start doing this evaluation, the arguments in favor, the arguments against it. And you as a product manager, you want to do both. You want to be your devil's advocate about I don't want to launch this. What are all the bad things that can happen if I do it, and all the good things that could happen if I do it? And then you have a specific launch criteria, and then you make the decision, right? Of course, there will be things that, for example, you try to put everything in the launch criteria to say, I'm not going to be launching this if I have more latency. But you may say, I'm okay with some latency if this happens, but try to do everything beforehand. At the beginning it may be hard because you don't really know, but as soon as you have more experience, try to be as specific as possible, because the decision process will just be super fast. Because in other ways you will be saying, well, we said that, but now the results are a little bit different, so what do we do? But when everything is very clear, you say, yeah, check everything, done. And the other part that is super important is just to communicate the results. This is something that you have insights and learnings, and you want everyone to kind of know from the company. So I will go really fast now. So there are different ways to do different tests. This is multivariate testing, that basically you want to test not just A, B, C, D, but you want to test multiple configurations of multiple variables. So for example, if you have your search results here and say, well, I want to test different labels, I want to test different type of images, I want to test different type of colors, I don't know what's going on. If you want to do an A/B test, it will be 48 combinations, right? So you don't want to do something like that. And even if you technically, if you can do it, it will be really difficult to start configuring 48 different options. So what multivariate testing can do in the configuration of your framework is that you specify the variable, these are my 4 variables, and multivariate testing will be doing all the mixes. So you don't have to configure everything. So the pros is that it measures the interaction between different elements. Some problem sometimes is that you say, hey, I'm going to change the color here, and it's good, and then I will change the label, and it's better, but maybe that label with the previous color was better, and you never tested that. So this helps a lot with do that interaction. Again, it's also easier to test multiple things in the same user interface. The cons is that you really need a lot of traffic. A lot of traffic to be able to do something like that, because you're going to be having like 48 things going at the same time in this case. As I say, sometimes it makes sense, like for big companies, many times it doesn't. And also it's important that all the combinations make sense together, right? If you have like some changes in the colors, and then when these two colors like do not make sense because you're not really configuring it one by one, it could be really bad. The other option that you have is something called multi-arm bandits. And the difference with A/B and multi-arm bandits is that here you optimize your objective function by updating the randomization kind of real time. What does this mean? Like, suppose that you have A, B, C, these three options. This will be like A/B testing. You do your test in this, I don't know, for 5 weeks, and then you analyze the results and you say, hey, see what's better, and then I launch it, right? What multi-arm bandit it does is, first it allocates exactly the same amount of traffic to the three treatments, and then you will have an objective function that you will evaluate. For example, you say click rates. So you will evaluate click rates at the end of the day, and you say, hey, with that information, I know that this is much better. So based on like that, this is better, I want to give more traffic to see. So then you change the distribution, and you keep changing and you keep changing. So then you can, you don't, like, opposite to multivariate testing, this will start reducing like the number of options really fast. If you put something out there that is really bad, it will go away fast. So that's actually really, really cool. And then you will be able to get, sometimes it will just have all the traffic to the one that is a winner. This is great also to do like continuous optimization. Sometimes you just have something like that when you're saying, hey, I want to put like I don't know, like 3 options of pictures, and I want to just add one more, and it will basically try to figure out which one is better. You put another one, which one is better, and it is always being optimized. So the pros is that it produces answers very fast. It's safer as well to allocate it to a lot of traffic, because you know that the bad options will go away, because in an A, B, C, whatever, you still have to do like the one that goes bad. It increases the experimentation output. You can do a lot of more things at the same time, but there are still cons, right? And one of the cons is that you value short-term behavior. If you're, for example, thinking about returns, I want to improve returns, this is not going to help you, right? Like, you're basically here optimizing for clicks. You're optimizing for like potential for some revenue, but it has to be something like that you can calculate really fast. It could help. I mean, it could be a self-fulfilling prophecy, right? That sometimes you like people see something first and they will just start doing it without, and it may not be the best option. And I think that the other part that it's important is you cannot quantify the impact of your change, because the variation will keep changing. So then you don't know how much better your result was. So usually when you have multivariate, multi-arm bandit and you have a winner, then you do an A/B testing with the winner and the C to be able to quantify the impact. So there are a lot of mistakes that happen on this. So there are a lot of things ethical, like, are you testing something that will be reinforcing biases, right? And you, yeah, I mean, I can talk a lot about that, but like just saying, hey, I have this kind of customers who buy cheaper products, am I going to be giving them like cheaper options, right? Like, I mean, you may be able to do it, but like if you later you know that you as a customer, you're getting like cheaper products, like why am I getting cheaper products than others? So think about if you're reinforcing biases of like people have access to things, and because of the past behavior, you're going to reinforce it. Dark patterns are things that you're just trying to make a change to like, I think I remember someone who was telling me that, oh yeah, I did an experiment where I removed every single option to the customer, just to like, the only option that they have was to say buy. And I'm like, that's the worst test in my like, that I've heard. And he was really proud to say, yeah, like we increased, like, I don't know how much. And I'm like, sure, you're increasing, but like, that's a really bad, like shitty user experience. Are you deceiving users? Like, are you making some changes to say, hey, maybe if I change this thing, people will click more and do other things, and it will, but it's just not ethical, right? Are you violating privacy? Sometimes you have the data, you want to show it, or you want to use that data for some other reasons. Like, just don't do it, right? I think that the what I tell people, like, what if the description of your experiment was in the New York Times? Like, would you be proud of it? Time related. If you stop tests too early, that's usually a common mistake, as I was telling you. Many times the way that users behave will change. Like, sometimes there will be, maybe there's something new and a lot of people will going to be clicking and using it. And if you decide that you're only doing it for 1 week, you will get that up. But in reality, it's not great in the long term. So if you stop it, because that's the point when you're saying, oh, now the results are good, like, I'll stop it there. It's like, no, like, it may be problematic. Or not testing long enough as well, right? Like, if you need to understand the sequence of your experiment, or for example, in the case when we're testing returns, we want to make sure that you analyze the results, that you have enough time to capture that information. Sometimes you're testing for too long as well, to say, I'm making this change, but I'm not getting any significance, so I'm going to test it for like 3 months. Like, no, like, the change is so small that that's when you start going into those parts that I'm testing for 6 months or whatever. Experiment or A/B testing may not be the best strategy to know which one is better. As I say, tests are not run the full weeks. When you test during holidays or things that people will be behaving differently. And I say, like, forgetting learnability, sometimes you just, at the beginning, sometimes people, for something new, they won't like it, they won't look at it. It doesn't mean that it's bad. And if you decide just to run it for 1 week or 2 weeks, maybe if you run it for 3 or 4, like, if you really think about the user behavior, it will be good. So user needs to learn this. Configuration, as I say, loose triggering, just testing for everyone instead of just when people actually see your change. When you ignore different traffic sources, where are people coming from? When you send too little traffic to variations, when you start changing things middle way of the experiment. Maybe you have an experiment, you say, oh, I'm going to change, I'm going to fix this bug and I'm going to change something midway. You're contaminating all the results. Not considering mobile traffic variables. This is very important. That there are so many things about, like, connection speed, location, like what kind of is a 3G, 4G, what kind of telecom company. There are too many variables that you have to make sure that you get it. Design, when you don't have a hypothesis, that's a problem. When you have too many metrics, and this is a big problem, because when you start having too many metrics, then whatever will work, and then your significance, it doesn't actually make sense. Using a metric that you can measure, but not one that matters. That has happened to me many times, to say, hey, I want to measure this, and you're like, and what? I mean, that doesn't make any sense. Like, we're not trying to optimize for that. Not setting quantifiable goals. Using too many changes on a single treatment, as we're saying, if you start saying, hey, I'm going to have this toggle, I will change the results, I'm going to also, like, change the algorithm to be better. You're like, you don't know exactly what happened. Or using too many variations, right? Like when we were discussing about the colors. I think this is a very famous experiment from Google, where they were having discussions between different designers about, like, should we do this blue or this green, blue in the Google links, and at some point, like, let's test all of them. And you're like, well, that's kind of like shitty, right? Like, you have to, like, as I say, have a hypothesis. What do you think about it? Sure, you may have to say, well, I think that these are the 3 reasons why these are good, but having something like that is just it's not a best practices. You can use those resources for something else. And this is the part, like, you can do it. It's not bad. Like, it's just, is this the best use of your resources? And because you have users in this test, is that the best way that you're using it? You have unlimited resources like Google, right? Like you may do it, but still, like, you're losing 2 weeks. You're losing like engineering time. If you trust everything that you read, that's a common mistake. If you ignore local versus global metrics, for example, suppose that you are doing an experiment in one of your pages and you say, I'm going to change, in this case, I'm going to do a different recommendation. And in this case, for example, okay, I'll give you an example of my current team, like, oh, you want to sign up for Google Cloud. So I'm going to change this page with like where I'm going to put these different buttons about signing people to Google Cloud. I'm just going to be, and I'm only going to measure what happens in this specific page. And yeah, when you measure whatever happens in that specific page, yeah, the sign up increase, but the sign up decreased from the people who were going into the navigation bar. So at the end, it's the same. You're just like moving clicks from one place to another, right? So if you start, you really need to understand what are the metrics and what the global versus the local, because if not, as I say, you're just changing traffic, changing like where people are having the revenue, where you're getting the revenue when. Maybe that's what you want. Maybe you want to change behavior, but that should be your hypothesis, and that should be your expected outcome. I'm changing the behavior, not that I'm changing the metric. Not taking seasonal changes into account, ignoring technical issues. Sometimes there are bugs. There's latency that you're like, why this is not happening? Like, oh, because it's slower, right? Or something that is called flickering, that depending on the type of test that you do, sometimes people will see both things. Like they will see like your control and suddenly they see the treatment because something is slow. So there are a lot of like problems that can happen that you need to go into the technical details to understand like, why is this happening? This is also important, the incorrect post-segmentation, that basically this means that you are testing for everyone and then you decide to do an analysis, and when you start doing the segment you say, hey, it was great for this type of customers, but in reality you don't have enough. It could be many problems that you don't have enough data from that customers to actually make a decision, but also if you're trying to suddenly divide all of your type of customers and you have 20 types of customers, or like just by random chance, one of them is going to be positive. So you really need to understand how you do your segmentation and if it's valid, that segmentation, because what could happen is that if you were doing randomization by another variable, it could happen that in that segment, it was actually not random. So you need to look into that. Or what I was talking about, like p-hacking or data fishing, like just trying to figure out like what else changed, how can I make this better. So the best practices is like make sure that you choose the right metrics. That's super important. How do you define success? How do you define user value? As I say, think short term and long term. You want to make sure that those are aligned. Be more inclusive at the moment that you are using your success metrics. What I mean is that you want to make sure that you're bringing the right type of customers, or all types of customers to your test, and remove as much bias as you can. Make sure that whatever you are measuring is because of your product. A good example that happened, for example, at Amazon is that I'm not going to be measuring how much revenue the books team has based on search changes, right? Because I don't control how many books people have. I don't control the catalog. I don't control anything. I can only control incremental changes based on my change. So be very specific about the metric that you're using, and if it's based on your changes. Or for example, in my current job in cloud, to say, hey, if you're doing a test, but in reality you're bringing so much traffic because there was a big marketing event, right? Like you don't control that. Avoid using lagging indicators in the sense like in this case. For example, for returns, it's hard, but if there's any proxy that it actually matters, it's great. If not, that's fine. Just it takes way longer to do the test. In the case when I was working for returns, you have to do a test for 4 weeks. and then you have to wait for 4 weeks for people to return things, and then you have to wait more, and then you do the analysis, right? So like the iteration takes longer.
And you said lagging indicators, and you said returns. Wouldn't that just be the indicator?
Yeah, I mean, in that case, yeah.
Okay.
I mean, if there's another way that you can do it, that's great. But, for example, if you have, so for example, something that right now we're doing with cloud is to say, well, we want to make sure that people who sign up to cloud are people who are going to be using cloud a lot. But that will take a year to know if they're going to do it. So like, sure, we want to know usage, but are we going to do a test and wait for a year to see what happens? And the other one is to align on success metrics beyond your team. You don't want to have different teams, like one going for profit and you going for revenue. They will have the discussion about like, why did you launch? Don't do that. Be a good wannabe scientist like I am. So be biased against rolling flat experiments or inconclusive, like when you don't really know what the hell happened. Because usually they increment like technical debt. This is not like a thing that, not because you built something, you have to launch it. So remove all your ego and the ego of everyone to say, yeah, you work on this for like 2 years, but nothing actually changed. So why are we doing this, right? Like remove it and do something else.
When you say rolling out, you mean
deploying, yeah.
Not rolling out the experiment.
Yeah.
Okay.
Yeah. Unless it's a complete redesign. Like sometimes you say, hey, I'm doing a complete redesign of this, and I just want to make sure that like things are not worse. That's a good thing. Like, how else are you going to do it? Be suspicious if you didn't predict a specific result. Sometimes you test something, you say, hey, I want to increase revenue, and you didn't increase revenue in that specific like category, and you increased revenue in another one completely different. And you're like, great, I'm going to launch it. Like, why? Like, what happened? Like, why does the experiment have that result? Be very careful about it, because it may have a completely different outcome or behavior than the one that you're expecting. And also you will start like even like perpetuating like falsehoods. Like I did this experiment and we launched it, and this was the hypothesis, but in reality it changed something else. Just retest and make sure that it's good and it was not like a flick. And make sure that it has a consistent story when you're looking at your metrics. As I say, the more you slice your data, you will find things. You will find things just by random choice. Like if you have 20 metrics, by random choice, one of those will be significantly positive. You can also run an A test to see like, okay, let's divide the traffic. There's no changes. I should not see any changes as well. That's another way that you can, when you're doubtful about about what happened, sometimes that's super helpful. And create and follow templates and processes like intake forms, pre-experiment designs, pre-experiment designs, like to be very specific about like what's my experiment, what is changing, what's my objective, what my triggering criteria, what my launch criteria. Write everything and make sure that everyone is aware. And at the end, when you run the experiment, document not only the thing that went well, but also the thing that went wrong, because you will learn from everything. The main objective of an experiment is not really to win, but it's really to learn. So like if you reject the hypothesis, that's also good. So make sure that you summarize what you learn. What this key observation, this funny, like, oh, I didn't know that this could happen. Now we know, and then you can create another experiment. And as I say, just try to really create a process about like what kind of experiments you're going to have, who is going to review them. It's good to have a review system, like when you have a product manager, maybe have a group of product managers that will be questioning it, like, is that the right hypothesis? Be very critical. Monitor, like as you're saying, like you have an exit criteria, so you want to make sure that if something is not doing well, like you remove it. Sometimes this happens at Amazon and also at Google for search, where you have an experimentation council that you will need to actually write your experiment with like as scientific as possible as you can, and then you go with an expert, with an actual scientist, and you're looking at like, is this okay? Like, am I looking at the data correctly? Am I making the right choice? Because as one of the problems is that when you are running the experiment, you have a bias that you want to launch it, right? So it's so much, it's actually recommended that the person who, like, that the one who runs the experiment is not the one who has the decision to launch it. It should be someone who doesn't care. Like, I don't care if you launch it or not. Like, I want to see that the data is correct. I want to see that you didn't have any biases. Socialize the results. That's the part that that was a practice that we did at Amazon, and I'm trying to implement in my team right now at Google, to say, hey, all of these experiments that we're doing are really interesting, right? Like, we're really learning so much about the behavior of our users. And yeah, I mean, our team is the one that is planning them, but like, other people can benefit for these insights, right? Like, you may have to have a different communication method to say, hey, we ran this experiment, we learned this about our users, and it could be good for others.